Hello everyone, welcome to my YouTube channel, The Speed of Grades. So today is our lecture 4 in which we will talk about operations on set and ordered pairs and ordinary sets. And let's see. Okay, first let's see what is ordinary sets. Ordinary sets, the order of the object is not important in ordinary sets. Like here, 1 to 3 is equal to 2, 3, 1, and it is equal to 3 to 1. So in this, the order of the object is not important. We enclose them in curly brackets. We, like here in the above example, you can see the elements are written in the curly brackets, and the contents that are present in the curly brackets are called as elements, and two sets are equal if their objects are same. And after that, let's see what is ordered set. Sometimes we need sets which have a definite order of objects which cannot be altered. Okay, so we enclose that by round brackets. Sets are called ordered sets. Contents are called components. The elements we write in brackets are called as components, and two ordered sets are equal if corresponding components are equal. Okay. After that, there are some properties of ordered set. Let's see. If a comma b, a comma b is not equal to b comma a unless a equal to b, because the values will be exchanged and we do not need that. After that, a comma b is equal to 0 if a equal to 0 and b equal to 0. These are the basic properties of ordered set. And the third one is a comma b is equal to c comma d if a equal to c and b equal to d. The values of both of them are same in that case. Okay, so now we will see that what are the different operations of set. Here, the first one is operations on set. Okay. Now we define three basic operations for sets, namely intersection, union, and difference. And two other commonly used operations are complementation and Cartesian product, and we will talk about that also. So first one is the intersection of two sets A and B denoted by A intersection B is the element, it is a set of all elements belonging to both the sets A and B. We will see that which element is common. We will take out that in the set, in the final set. Okay, I will discuss that in example. Here are some of the properties, but let's see what is intersection in the example. So let's see the example. Okay, here we have a set A. Okay, that is 1, 2, 3, 4, and 5. Okay, and we have a set B equal to 2, 3, and 6. In this, the intersection will be the common. And what is the common in this? 1 is present in A but not in B, so we will not write in the final set. Okay, 2 is present in A and also in B, so we write it in the final set. 2, we get one element 2. After that, check 3 is present in A and also B, so we will write 3. After that, 4 is present in A but not in B, so we will not write that. After that 5 is present in A but not in B, so we will leave that. So we have the final set as 2 comma 3. Okay, and this is called intersection. And how we write that? A and A intersection A intersection B. A intersection B. Okay. Now let's see the properties of that intersection. Okay. There are 3 properties of that, and we represent the intersection set by this x such that x belongs to A and x belongs to B. Okay, the final set should belong to A and also belongs to B. Okay, and there are 3 possibilities for A and B. First one is either no element is common to both, like for example, no element is common to both. For example, we have A equal to 2 and 3, and we have B equal to A comma B. A comma B. So there is not anything in common. So our A intersection A in A intersection B will be equal to null set. Okay. And another property is that and here A intersection B is equals to null set, and in this case A and B are called disjoint sets. The second property is some elements are common to both, and A intersection B is equal to C is not equal to null set, and that is the example we saw before, that how we take the common in both of them. So this is the thing, and we talked about overlapping set. In this case A and B are called overlapping sets. In the previous tutorial we talked about overlapping sets in detail with examples. And third property, there is one set, say B, is a proper subset of the other, say A. Okay, and the proper subset we saw in the previous class, that what is proper subset and what is improper subset. Proper subset is that if one element of both of them is not, if one element of A is not present in the other, that is that we will say that B is a proper subset of A. Okay, here the fourth property is A intersection B equal to B or A if A equal to B. Okay, now here's the example of that. Okay, you can see I have talked about example, and it is the same. We have 4 sets given as T, V and Y. Here S intersection V will be equal to null set, because in S and V there is nothing common in it, and we will call that disjoint sets. Okay, here T intersection Y will be equal to 1. Okay, T and Y, there is only one common, and we will call that overlapping sets. In both sets there is one. Okay, and S intersection T equal to T. Okay, S intersection T. Okay, so here you can see that T is a proper subset of S, because one element in S4 that is not present in T, and that is the definition of proper subset, that at least one element should not be present in the other. So we will call that a proper subset, and here T is a proper subset of S. Okay, so let's see another one, that is union of set. The union of two sets A and B, denoted by A union B, is a set of all elements belonging either to A or to B or both A and B. And here is a representation of that A union B equal to X, such that X belongs to A or X belongs to B. Okay, in example, let's see an example. Okay, so we have a set A equal to, okay, 1, 2, 3, 4, A, B, C. Okay, and we have a B set that is 4, 5, and 6, and C, D, and E. Okay, and the union will be A union B will be equal to, we will write one by one. We will write all the elements one by one in the final set, and we will not repeat the element if we have written it before. Okay, so 1, 2, 3, and 4. Here you can write, here you can see that in A there is 4 and in B there is also 4. So you write it only one time. Okay, so now you can see that 5 is present in B but not in A. So you write it down. 6 is present in B but not in A. We will write it down. And here you can see that A, B, and here you can see that C is present in both of them. So you write only one time. We will not write multiple times. We will write only one time. Okay, so here D and E. This is called the union set. Okay. So there are some properties of union set also. So we will talk about that here. A is a subset of A union B, and B is a subset of A union B. Okay. This will be proved by the examples. So you can take any set A and B and you can prove that. The second is B is a subset of A and A union B equal to A. They will be both same. And after that, A is subset of B and A union B will be equal to B. Okay, in the third, A union B equal to A intersection B equal to A or B if A equal to B. Okay, you can prove that by example. It will be easy. So let's see another exhaustive sets that is related to union set. If A and B be subsets of a set U such that A union B equal to U, then the sets A and B are called exhaustive sets. Okay, like we have a set U and we have two another sets A and B. We have a set A and B, and we will take the union of that, and you will see that the A and B will be the subsets of union set. So we will call that the set A and B are called exhaustive sets. Okay, in the example we see that U, A, and B and C equal to 2, 3. Here you can see you have all the elements that are present in A, B, and C. So U will be the superset and A, B, and C will be the exhaustive sets of U. Here the another is cells. If A and B be subsets of set U such that subsets A and B be non-empty and mutually disjoint, and A is not equal to null set and B is not equal to null set, but in A intersection B is equal to null set and A union B is equal to union, the sets A and B are called sets. Okay. So another is difference of set. The difference of two sets A and B in the stated order denoted by A minus B is a set of all elements of A that are not in B. Okay. A minus B will be equal to X such that X belongs to A and X does not belong to B. And B minus A will be X such that X belongs to B and X does not belong to A. Okay. So let's see it by example. Let's see it by example. Okay, we have a set A equal to 1, 2, 3, 4, and 5, and B equal to 2, 3, and 4, and 5, and 6, and 7. Okay, so A difference B will be equal to, okay, we will not write the common elements in the final set. Like here you can see that we have to write all the elements that are present in A by differencing and from B. Okay, so we will write 1 here. Okay, there is A in A, and there is 2 in A set and 2 in B set. So we will not write 2. Here 3 is present in A, 3 is present in B, so we will not write it. Here A is present in 4 and B is present in 4, so we will not write that. 5 is present in A and also in B, so we will not write it. And here 6 and 7, we will not include them in the final set, we will just include 1. Okay, if we are doing B minus A, then our final set will be uh 6 and 7. Okay, then our final set will be this. We will write the remaining elements of B in B minus A, and if we are doing A minus B, then we will write the remaining elements of A only. Okay, now let's see another property. Okay, so it's clear to all of you, I hope. If there is any question, you can ask me. Okay, here is a complement of a set. A complement of a set A denoted by A complement is the difference U minus A, where U is the universal set. A complement is equal to U minus A. Here's a representation X such that X belongs to union and X does not belong to A. Okay, so here is the example of that. Here are some of the properties that if we take the complement of U, like we will minus U, so it will be, obviously it will be null set. And if we take the complement of null set, then it will be U minus null set, and that will be equal to union. After that there is A complement, and after that there is a whole complement. Then their answer will be A, where A is in any set. Okay, so complement of a set, let's see it by example. Here the universal set is 1, 2, 3, 4, 5, 6, and 7. And we have a given set A equal to 2, 3, and 4. So the complement of A will be equal to U minus A, and we will write like this: 1, 2, 3, 4, 5, 6, 7 minus 2, 3, and 4. Okay. So what will be the answer? 2. We will not write 2, we will not write 3, we will not write 4. So the answer of A complement will be equal to 1 and 5 and 6 and 7. So that is the final answer of the complement. Okay, I hope it is clear. If you have any question or you have any question in your assignments, then you can comment down below. I will solve it for you. Okay, the properties I have discussed, you can solve it by any example and you will see the results. Here, it is a Cartesian product of two sets. The Cartesian product of any non-empty set A with any other non-empty set B is a set of all ordered pairs where A belongs to A and B belongs to B. It is denoted by A cross B and is read as A cross B. Okay, here you can see that A comma B such that element A belongs to set A and element B belongs to set B. Okay, here is an example of that, S equal to 0, 1 and T equal to 1, 2, 3. We will make a pair of 0 with each element of T. After that, we will make a pair of 1 with each element of T. Okay. If there is T into S, then we will make a pair of 1 by each element of S. We will make a pair of 2 with each element of S, and we will make a pair of 3 with each element of S. Here you can see we have make a pair of 0, 1, after that 0, 2, after that 0, 3, after that 1, comma 1, after that 1, comma 2, after that 1, comma 3. Okay. And after that, there are 4 properties of that. A cross B does not mean that A is multiplied by B. We are just making a pair of that. Okay, so A cross B is not equal to B cross A, that I have told you before, that it will be not in ordered pairs. In ordered sets, this thing A comma B will not be equal to B comma A. I talked about this in the first slide about ordered set. Okay, after that, the third is A cross B cross C is a set of all ordered triplets where the element A will belong to A and element B will belong to set B and element C will belong to set C. Okay, the fourth property is if number of elements of A is equal to M and number of elements of B is equal to N, then the number of ordered pairs in A and B is M and N. Okay, I hope it is clear to everyone. So that was all for today. And if you have any question, any assignment you have, or anything you want to clear out, you can comment down below and subscribe my channel, like my video, share it with everyone. I will see you in the next tutorial with another topic, another examples, another thing. Thank you.